Welcome to our competency-based question series designed specifically to enhance your conceptual learning and understanding. In a circuit, a resistor of 1 kilo ohm is connected to an element X as shown in the figure. So this is the circuit, 1 kilo ohm resistor. It is connected along with an element that is X. And we don't know what kind of element it is. It may be a capacitor, it may be an inductor. The AC voltage that is given to us as input is 10 millivolt and it is applied at variable frequencies. And the data for the output voltage has been given in the table. So we can see that at 10 kilohertz, the impedance of this circuit is 3 multiplied by 10 to the power 3 ohm. And the output voltage that we get across X, it is 16.1 millivolt. So based on this data, we have to study these four statements and then we have to select that what statement are true and what statement are false. It means one by one. But before that, let us study this table to find out certain facts about the circuit. So we can see that at 10 kilohertz, the impedance is 3 multiplied by 10 to the power 3 ohm. But when we are increasing the frequency, we are moving from 10 kilohertz to 100 kilohertz, the impedance Z is decreasing. Again, when we are further increasing the frequency nu, the impedance is further decreasing. And at 10 megahertz frequency, the impedance has come out to be 10 to the power 3 ohm, that is equal to R. So we can say this, that this is the resonant frequency, because we know that at resonant frequency, the value of impedance Z, it becomes equal to R. And that is evident from the fourth entry in the table, that at 10 megahertz, the frequency has made the impedance to be 10 to the power 3 ohm. So this is the resonant frequency. And the value of impedance is decreasing with increase in frequency. So we know the formula. Formula for Z is equal to under root of R square plus X square. Because it can either be a capacitor or be an inductor, we don't know about it. But since the value of Z is decreasing with increase in frequency. So this is only possible when X is a capacitor. Because we know that the capacitive reactance is inversely proportional to frequency. So as frequency increases, Z will decrease in case of capacitor. So this is evident from the data that X is a capacitor. Now let's take these statements one by one. The output frequency is expected to increase with the increase in, the output current is expected to increase with the increase in input frequency. So we can say this thing that as nu is increasing, the value of Z is decreasing. And we know that I, it is equal to V by Z. So when Z is decreasing, I will increase. So this is the correct statement because the impedance offered by the circuit is decreasing with increase in frequency, hence the current will increase. So this statement is true. Now let's take second statement. The reactance offered by X increases with the increase in input frequency. So we know the reactance for the circuit X, it is decreasing with increase in nu. And we can say this from the data because Z is decreasing. As Z is decreasing with increase in frequency nu. So that's why this statement is false. Because the reactance offered by X is decreasing with increase in input frequency, but it says that it is increasing. Let's take statement 3. So in statement 3, it says if the input is replaced by a DC input of same voltage, the output voltage V0 becomes 0. So since we have concluded that X is a capacitor. So the capacitive reactance for DC value will be infinite because Xc, it is equal to 1 upon 2 pi nu C. Or you can write Xc is equal to 1 upon omega C. Both are same. Omega can be written as 2 pi nu. So as nu is becoming 0, because in case of DC, nu is tending to 0. So when nu is 0, Xc will become infinite. So this is a statement which says this thing that if DC input is applied in place of AC, voltage V0 becomes 0. So since Xc becomes infinite, Z will also be infinite. And when it offers infinite resistance, it means no current will pass through X. And when this value of current through X is 0, it means voltage across it will also be 0. So this is a correct statement. Hence, V0 will become 0 because current through X will be 0 as it will offer an infinite resistance. And in the fourth statement, the circuit element X could be either a capacitor or an inductor. So it is false. Why so? Because from the data we know that it can only be a capacitor. It cannot be an inductor. But it says it can either be both of the two. So the circuit element X is definitely a capacitor. Hence it's a false statement. So we have examined each of the statements. First statement was true and second was false. Third statement was true and fourth statement was false. Hence we can say this thing that out of the four options given to us, the statement 1 and 3 are correct. So option C is the correct answer for this question. Thank you. Keep learning, keep practicing, keep excelling.